Gupta.com, and if you like this video, please don't forget to smash the like button and share this video with as many people as you can. And if you haven't subscribed to my channel yet, kindly do it so that you don't miss any of my videos. So without any delay, let's get started. And today's topic is compiler versus an interpreter. What is the exact difference between them? What is a compiler? What is an interpreter? And we will see diagrams and everything in this video. So this is gonna be a very interesting video. So without any delay, let's get started. What is a compiler? A compiler is a program that transforms code written in high-level programming languages, for example, JavaScript, Python. I gave the wrong examples. C, C++, Java, right? A compiler is a computer program that transforms code written in high-level programming languages, for example, Java, C, C++, into the machine code. Right, so it basically whatever code we write in the higher level programming language, that it converts into machine code. It takes the whole code and converts it into a code that the computer understands. It is a program which translates the human readable code that we write to a language a computer processor understands, that is binary 0 and 1 bits. A compiler should comply with the syntax rule of the programming language in which it is written, right? So the compiler should know that what is the syntax rule of the programming language in which it is written, right? However, the compiler is only a program that cannot however, the compiler is only a program that and cannot fix errors found in that program, right? So it is only a program, right? It is only a program and it cannot fix errors found in that program, right? It cannot itself fix errors. So if you make a mistake, you need to make changes in the syntax of your program, otherwise it will not compile, as we know. So this was compiler. We'll see a diagram of it after we see what is interpreter. An interpreter is a computer program. It is also a computer program which converts each high-level program statement into the machine code. So there's a slight difference over here. The compiler, what it was doing, it was taking all the high-level programming code and converting it to the machine code. But an interpreter takes one line of the high-level code, converts it to a machine code, then executes it, then takes the next line, then converts it to a machine code, and then executes it, right? So it goes line by line in an interpreter, but it converts the whole code and executes it in a compiler. This includes source code, pre-compiled code, and scripts, right? So an interpreter with which can interpreter work? It can work with source codes, pre-compiled codes, and scripts. Both compiler and interpreters do the same job, which is converting high-level programming language into machine code that we already know. However, a compiler will convert the code into machine code, create an exe file before the program runs. A compiler will always create the whole converted code and save it in an exe file. It will create an exe file, right? It will create an exe file that will be an executable file that will get executed. Whereas interpreters convert code into machine code when the program is running. So when you run the program, it converts one line to machine code, executes it. Then it converts another line to the machine code, then it executes it. Then it converts the third line to machine code, and then it executes it. So this is how it works, right? Now let's see a diagram of both compiler and interpreter's workings. Here this is a compiler's working, where we give the source code, then that source code goes to the compiler, it converts it to the machine code, the whole source code, and then we get the output. Whereas over here, if we have a source code, it directly goes to the interpreter. It interprets one line, right? So it interprets one line, converts it to machine code, the first line, and then executes it. Then it converts the second line and executes it. Then it converts the third line and executes it. So that's how we get the output, right? So one step is reduced in interpreter, and that is creating or the whole source code, taking the whole source code and first creating an exe file of it and then giving the output. Directly we can just convert each line and give the output. And over here, as you can see, the working, it is quite cool, right? One step is less when using interpreters. So I'm just giving you 2 seconds to look at it once again. Okay, so now let's continue back with the discussion. Okay, so now we saw how a compiler works and how an interpreter works. Let's see the key differences. The compiler transforms codes written in high-level programming language into the machine code at once before the program runs, right? So it takes all the high-level programming code, takes the whole chunk, converts the whole chunk into a machine code and creates an exe file, an executable file, and then that executable file runs, and then we are able to see the output of a program. Whereas an interpreter converts each high-level program statement one by one into the machine code during the program runs. So it takes one statement, converts it to machine code, executes it, takes the second statement, converts it to machine code and executes it, and so on, right? So compiled code runs faster while interpreted code runs slow. Obviously, when you have an exe file, right, you have the whole file that will just execute. Whereas when you are running interpreted languages code, then like when you are running some code that will be interpreted, right, using an interpreter, right? Yeah, so when using an interpreter, then you won't have an exe file. You have to convert it for every line into. So like for example, you have your whole program, you provide the users with your exe file, with an exe file. Then they already have the machine code. They just have to click it, and the code does not need to be converted into machine code. It is already in machine code and it gets executed. Whereas in an interpreter, in an interpreter based language, where when you write code, right, so when you write code, then and whenever, for example, you are using JavaScript and you are on the web, that is an interpreter based language, right? You're on the web working with JavaScript, you have deployed it, and whenever somebody comes to your website, right, so you have created a website using JavaScript, right? So whenever somebody comes to your website, then one line that is, the JavaScript is not already in machine code. The first line will be executed for them. First line will be converted into machine code and then executed for them. Then second line will be converted into machine code and executed for them, and it will go on, so on. So it has to, when using compiler, you only have to do one step, right? If you have an exe file already, right, just run it, right? You already have the machine code, you have to just run it. Whereas when in interpreter working, you have to you have, every line needs to be converted into machine code and then it will run, right? So if you already have an exe file of your compiled code, then that will be much more faster than running interpreted code. So compiler displays all errors after compilation. So after the compilation, the compiler will display all the errors. On the other hand, the interpreter displays errors of each line one by one, right? So when, like, if the interpreter finds an error on some line, it will stop the program working there and then. Whereas in compiler, it will compile the whole code and then only it will show us the errors. The compiler is based on translation linking loading model. So this makes sense. The name translation linking loading model makes sense. We can take an example of C. For what happens in C? First we convert it into machine code, right? So we first converted into object code, right? If we are taking an example of C, we convert it into object code, right? Then we link it with other libraries, right? Then it is converted into machine code, and then it is executed, right? And the machine code, when it will be converted, we can give our name to our executable file, or it is a.out, right? We all know that it's C. If you know C, and if you don't, you can check out my videos on C. Whereas interpreter is based on interpretation method, right? So there's an interpretation method on which interpreters are based. Compiler takes an entire program, whereas the interpreter takes a single line of code. So interpreter first convert. I've repeated myself a lot of times. Now these were the key differences. Let's see all the differences of between the compiler and interpreter. Let's see first when you are coding in C or C++, what exactly happens. That is a compiled based language, right? Those are the languages that will be compiled. And when you are working in Python or JavaScript, then what will be happening, that is, those are the languages that will be interpreted. So let's see the example of C or C++. You are coding in C, you create a program, right? So compiler will parse or analyze. Compiler will parse or analyzes all of the language statements for its correctness, right? So if incorrect, throws an error, right? So it will parse or analyze all of the language statements for its correctness. If incorrect, it will throw an error. If there is no error, the compiler will convert the source code to machine code. As we know, it links different code files into runnable program known as exe. So first of all, if there's no error, we get an object file, obj file, right? As we know. Then linking happens, and in the end we get an exe file that is then run. Whereas in an interpreter, we create the program. There's no linking of files or machine code generation, right? No linking of files is required or anything. The source statements executed line by line during execution, right? So it is so simple. So let's see the advantage of compilers. And the advantage is that the program code is already translated into machine code. Thus, its code execution time is less. Interpreters are easier to use, especially for beginners, right? Advantage of interpreter is that it is easier to use, right? It is easier to understand, right? And the advantage of compiler is that the code is already translated into machine code, thus its code execution time is less. Okay, so now let's see the difference between the running time of both. Compiled code runs faster and interpreted code runs slow. That we already knew. Let's see the model. We know that compilers are based on translation linking loading model, and interpreters are based on interpretation method. Program generation. Compilers generate output programs in the form of exe files, which can be run independently from the original program. And in interpreters, they do not generate output programs. So they evaluate the source code at every time during the execution. Let's see the execution. Program execution in a compiler is separate from the compilation, right? So in a compiler, program execution is separate from the compilation, right? It's performed only after the entire output program is compiled, right? So when the whole program is compiled, then only the execution is performed. Whereas program execution in interpreters is a part of interpretation process. So it is performed line by line. So line by line it gets executed, right? So memory requirement. So in compilers, the target program execute independently and do not require the compiler in the memory, right? We don't need the compiler in the memory as we have the exe file and there is no use of the compiler. Whereas interpreter exists in the memory during interpretation. As always, when running the program, we first need to interpret each line and then execute it, right? So everywhere when using a interpreter based language, we need interpreters in the memory. So compilers are what are compilers best suited for? Bounded to the specific target machine and cannot be ported. C and C++ are the most popular programming language which use compilation model. Whereas what interpreters are best suited for what? For web environments where load times are important, right? So due to all the exhaustive analysis is done, compilers take relatively larger time to compile even small code that may not run multiple times. In such cases, interpreters are better, because when you go on the web, right, and you go on a web page, you will see some parts of it load first, and then after a little bit of very tiny bit of gap, the other part of the web page loads, right? That is because interpreter is executing one line at a time, right? That's why it loads some part, and slowly the whole page gets loaded, right? But if we did the same thing using compilers, what it will do, we will have lag. For example, you go to a very heavy site, right? You go to a very heavy site, right? And you are using a compiler, right, to convert it into machine code. So what will happen, it will take a ginormous amount of time to first compile it, and then it will take some time to execute it. So that will not be a good way to good delivery to the user, right? That won't be a good delivery to the user, right? So let's see code optimization. The compiler sees the entire code up front, right? Hence, they perform a lot of optimizations that make the code run faster. Interpreters see code line by line, and thus optimizations are not as robust as compilers, right? So that makes completely sense. Then let's see the usage. So compilers are best suited for production environment, whereas interpreters is best suited for program and development environment. Error execution. Compiler displays all errors and warnings at the compilation time. Therefore, you cannot run the program without fixing errors. The interpreter reads a single statement and shows the error if any. You must correct the error to interpret the next line. Input. The compiler takes the entire program, and the interpreter takes a single line of code. Output. The compiler generates intermediate machine code, whereas the interpreter never generates any intermediate machine code. Directly it converts each line to machine code and displays it. Errors, right? The compiler displays all errors after compilation, all at the same time, whereas the interpreters display all errors of each line one by one. So, which programming languages use compilers? Some are C, C++, C Sharp, Scala, Java. All like these languages use compilers. Whereas some examples of interpreter-based language will be JavaScript, Python, PHP, Perl, Ruby, and these all use interpreters. So, what is the role of a compiler? The compilers read the source code, outputs executable code, right? Translates the software written in a higher level language into instructions that computer can understand. It converts the text that a programmer writes into a format the CPU can understand. The process of compilation is relatively complicated, right? It is very complicated. It spends a lot of time analyzing and processing the program. The executable result is some form of machine specific binary code. Whereas the role of an interpreter is that the interpreter converts the source code line by line during the runtime. interpreter completely translates a program written in high level language into machine level language, right? So it converts, it first takes one line, it converts it to machine level language, and then it executes that line, right? It takes the second line, converts it into machine level language, and then it executes the second line, and so on it goes on. Interpreter always allows evaluation and modifications of the program while it is executing. So the interpreter allows evaluation and modification of the program while it is executing. Relatively less time spent for analyzing and processing the program in interpreters. Program execution is relatively slow compared to the compiler. High level languages. High level languages like C, C++, Java, etc. are very near to English. We know we write English words, and we use a lot of English words also in C, C++, and Java. It makes programming process easy, right? So if you have to write in zeros and ones, so that will take you forever to create a very simple web page. But if you are using C, C++, Java, JavaScript, then it will like be in a flash. So however, it must be translated into machine language before execution. All high level languages should be converted to machine language before execution. This translation process is either conducted by either a compiler or an interpreter, also known as source code. Quite cool. Let's see machine code. Machine languages are very close to the hardware. Every computer has its machine language. A machine language program are made of series of binary patterns like 110110 something. It represents the simple operations which should be performed by the computer. Machine language programs are executable so that they can be run directly, right? So now what is object code? On compilation of source code, the machine code generates for different processors like Intel, AMD, or ARM, right? So like on compilation of the source code, the machine code generated from the different processors is different, right? So it is always different. So to make code portable, the source code is first converted to object code. So you must have always seen in C, when you see, you have an obj file. In that obj file, we have our object code. It is an intermediary code similar to machine code that no processor will understand. Right now, no processor will understand that object code. At runtime, the object code is converted to machine code. It is further converted to machine code of the underlying platform, right? Quite cool. Now, one tricky thing is Java is both compiled and interpreted. How? To exploit relative advantages of compilers and interpreters, some programming languages like Java are both compiled and interpreted. The Java code itself is compiled into object code. So it is compiled into object code. But at runtime, the JVM interprets the object code into machine code of the target computer. How does it interpret? JVM interprets. How? It takes one line of the object code, converts it to proper machine code, and then executes it. Then it takes the second line of the object code, converts it to machine code, and then executes it, and so on it goes on. So it is compiled into object code, but when running, it is run. The JVM interprets the object code, right? So very cool video, guys. I hope you guys liked the video. If you did, please don't forget to smash the like button and share this video with as many people as you can. Thank you guys. Bye. Stay safe, stay healthy, and keep watching my videos. Bye.